Alright, let's look at section 2.2, where we're going to look at identifying class width, class midpoints, class boundaries, relate a given distribution to a normal distribution, construct and interpret a relative frequency distribution, and construct and interpret a frequency distribution. Alright, so we want to identify the class width, midpoints, and class boundaries for this given frequency distribution. How we know it's a frequency distribution is this, I normally call these like tally marks. So this was the number of times the temperature was between 50 and 53 degrees. This was the number of times between 54 and 57, and so on. So to find the class width, we find the difference between the two consecutive lower class limits. So I could look at the difference between 54 and 50, or 58 and 54, and as you can see, all of these give a class width of 4. If I want to find the midpoint in the middle, since there's no exact middle, then what I do is I average, so I take this 53 minus 50, there's two values, so I average it, divided by 2, and that gives me the middle value is going to be this lower value plus the 1.5. So I get 50 plus 1.5 is how I get 51.5. 54 plus 1.5 is how I get 55.5, and so on. If I want to find the class boundaries, these are the numbers used to separate the classes but without the gaps, and they're created by the class limits. So how I find these is I'm looking at between 53 and 54. So I subtract the low here and the high here, divide by 2, so I see that I get point, which I'm simply going to add on. So 53, add the 0.5, 53.5, 57, add 0.5, 61, add 0.5, and all the way down. And the part I said don't forget about the lower boundary is I have to do the one before, which would be my 49.5. Alright, interpret frequency distributions. The data in this table represents the daily rainfall in inches for 1 month. Construct a frequency distribution beginning with a lower class limit of 0 and use a class width of 0.20. Does the frequency distribution appear to be roughly a normal distribution? To do is actually to put these in order, okay, because it'd be a lot quicker to do this, but I'm going to do it this way. So what I'm doing is, since my class width is from 0 to 0.2, my first is going to be 0 to 0.19. So I go through here and I find all of the values that fit in this range. If you count, you'll see there's 22 of them. Then I do the same thing for the 0.20 to 0.39. I see 1, 2, 3, 4, 5. So I'll put the, and I continue to do this. In fact, I see that 0.40 to 0.59, there's only 2. And then finally, I notice that there's just one large value from 1.20 to 1.39. So that's my 1.34 right here. And then everything else is zeros. Says, does it appear to roughly be a normal distribution? It's going to be very important later in the course about normal distributions. A normal distribution just means if I graphed it, it would look like a bell-shaped curve. But if I notice this, I see a lot of my data in the lower part, so it would not look normal, because if it was normal, more of your data would be right here in the middle. Because remember, the height of this curve is giving me the frequency, which is this column of my data. Alright, you can actually graph this on your calculator without looking at it, and so I just kind of show you the steps. This is going to become important later, that you understand how to put data in your calculator. So even if you don't want to graph anything, this part right here, there'll be other times that I'll tell you how to put data into your calculator. So you want to enter data by pressing the Stat button, and then you go to Edit, and just be sure the number 1 is lit up. It should be highlighted, and press Enter. And then here, these L1, L2, L3, these are actual lists where you can go in and you can enter each data value. So I enter 0.35 and I press enter. I enter 0, press enter, 0, press enter. Enter the zeros in there as well. So you enter all the, and when you get to the very last value, notice that this is my 0.11 and 0. Press enter after the last value. Then press window, and all this is doing is setting my screen so I can see my data. So we saw from our frequency distribution that my values here are from 0 and 1.39. This is going to be my x-axis, so that's all this means is what's the lowest x value and the highest x value. I normally go a little bit below and a little bit above. The same thing with the y values. The y values are my frequency. So my frequency is from 0 to 22. Again, I go a little bit below and a little bit above. And then I can go to this stat plot where I press second and then y equals to get to the stat plot. And I press. And what I'm going to do is I'm going to tell it that I'm going to arrow down to a histogram and select L1. L1 is actually that list where you entered all the information. And all this does is, I mean, you can see this is a big tall bar graph for the 22. All this does is actually give me a graph of my data. So it could be something that you might want to use later, but for a question like this, you probably didn't need to use it because you could see the data is not here. All right, construct a relative frequency distribution. Use the given qualitative data to construct the relative frequency distribution. The 2,301 people aboard a ship that sank included 407 male survivors, 1416 males who died, 328 female survivors, and 150 females who died. I'll take each one of these categories and divide by the total. So I take the male survivors, 407, divided by the total. This problem asked you to round to 1 decimal place. So I just move my decimal 2 places to the right, and I round this up if the value next to it's greater than 5. Do the same thing for males that died, 1416 divided by the total. Female survivors, 328 divided by the total. And females who died, 150 divided by the total. And it's always important because of just to make sure to add these up and make sure that they add to 100%.